Hello everyone, welcome to Database Management. This is week 15. In the past few weeks, we have learned how to use aggregate functions, simple total, and also how to filter the aggregate function result. And later, we learned how to update, insert, and delete record in a table. And today, I'd like to spend some time to go over the homework solutions for the past few weeks. And as you may already realized, we are almost approaching the end of the semester. And it is a big achievement for all of us because we have finished almost all the content in the textbook. It is a textbook with more than 800 pages, so it is a pretty large book. And this week, we're going to focus on the homework solutions. Next week, we're going to cover what left in the last chapter, the last section of the book, trying to solve tough problems. And for now, you already have all the basic knowledge to do some database management related work. You already know how to pull data using select from one table or multiple tables with a join statement. And also you learn a lot of details about how to design a better table or better database. So you have pretty much all the needed information to start any work in business analytics and database data pooling related area. Okay, now let's go to the homework solutions. All the homework are based on the sales order example database, and then we're going to use the database to start. Homework number 8. For homework number 8, it covers some basic aggregation functions like average, maximum, minimum, etc. It also gives us the opportunity to use the aggregate functions in a filter as well as other applications. So for the homework, there are 3 problems. First one is, what is the average retail price for helmet? The second one is, find the products that their quantity on hand are larger than the average quantity on hand across all products. The third one is, find the largest number of quantity ordered in a single order for all products across all orders. So you can see there are some aggregate functions mentioned in the problem. Average, largest, and in larger than. So those are some of the key points here. So as we're going to use the product database, let's look at it. What are the details for the product database? For the product database, it has product number, name, description, retail price, quantity on hand, and category ID. So the first problem is about helmet. So we need to put a where filter to filter out any of the product that has helmet inside. And here I introduce another function, which is the lower function, which is going to convert every capital letters to lower letters. So no matter what's your product's name, whenever there's a capital letter, it's going to be converting to lowercase after you apply the lower function. So you only need to have all lowercase in this expression here. And for all the products with helmet inside, then we're going to find out what is the average retail price. And we're going to use the average aggregate function here on retail price. And it gives us 76.51 as the retail price. So for the next question, what we want to know is, what are the products that their quantity on hand is larger than the average quantity on hand. So it is a very typical kind of filter problems, but we need to find out what is the average quantity on hand in a dynamic fashion. To find that, we're going to use a subquery. We put in select average quantity on hand from the products table to return the averaged quantity on hand as a single number. So when we have the quantity on hand larger than that calculated single number, then we filter out the product name. That's right. Okay, so those are the product that their quantity on hand is actually larger than the average quantity on hand for all the products. So the last problem is to try to find out the quantity ordered, the maximum quantity ordered across all different products, across all different orders, using the order detail table. Let's look at what is inside the order detail table. It has order number, product number, quoted price, and quantity ordered. So for each order number, it has a few different kind of product number. For each product, there will be a quantity ordered. So we're trying to find out what is the maximum for across all the orders and all the products. So it is a simple aggregation of trying to find out the maximum quantity ordered from the order detail table. So it is 6. After we learn the simple total from the chapter where homework 8 was assigned, for homework number 9, we're trying to use the group by function. The group by function is where you can find out some aggregated behavior for certain groups within your table. So in this homework, the first one is use the product vendor table, find the longest delivered days for each vendor. So we're going to use the product vendors table. Let's look at what is inside. It has the product number, vendor ID, wholesale price, and days to deliver. What we want to know is what is the maximum days to deliver for each vendor. Okay, so we have multiple vendors in this table, and for each vendor, it is a group. And we want to find out the maximum days to deliver for each group. This is the basic application of the group by clause. Group by is basically everything after the group by is the group identification. In this particular one, the vendor ID is a group identification. So for each group, we're going to find out what is the maximum days to deliver. That's right. So we found out there's a vendor 1, maximum is 2, vendor 2, the maximum is 3. And a quick check for vendor ID number 6. In number 6 here, it is 15. Did we finish it correctly? Let's do a quick check. Okay, for vendor 6, it has all different kind of products, and their days to deliver vary accordingly. And the maximum, when we look at it, all the products for vendor number 6 is actually 15. So yes, we are correctly make that happen. So the next question is, use product vendor table, find the longest delivered days for each vendor ID and each product number. So this is the application where we have actually both vendor ID and product number as the identifier, the combination of them. Okay, for each vendor ID, there are multiple product number, and in this table, the assumption is for each product number there could be different days to deliver, and the vendor ID and product number become the combined group identifier. So when we use the group by for both vendor ID and product number, basically we're going to create for each vendor and product number, there will be one maximum delivered days. That's right. As you can see, it indeed gave us the vendor ID, product number, and maximum days to deliver for that product in that vendor. And it's going to create one value for every vendor and product number combination. The third one is a more complicated application. It is use order detail and orders table to find for each customer ID what is the total spending amount. So in that particular problem, we need both the orders table and the order details table. Let's look at what is in the orders table. This is the order number, order date, ship date, customer ID, and employee ID. So for each customer, it is going to have different kind of orders, but we do not have the order detail. The order detail is in the order detail table. Here we have the order number, product number, coded price, and quantity ordered. So for this table, we can actually calculate what are the total dollar amount for each order. But there's no customer ID in this table. So to achieve the final goal, we have to join the two tables. So what we're going to do is going to join the order table and the order detail table on the order number column. Okay, after we join that two tables, what we need to do is actually to find out what is the total dollar amount, which is sum of the coded price and coded order for all the orders, all the products associated with one single customer. So that is why we put in the group by clause for the customer ID. So for each customer, all the products and all the orders, the coded price, the product to the coded price, and the quantity ordered will be summed together as the total spending. That's right. You can see for each customer ID, we have one number as the total spending. So this is a more complicated application of group by when you have to join multiple tables. So the group by can be used for one table or multiple tables joined together. So there's no limit on how many joins you can use. Okay, now let's go to the next homework number 10. It is also related to the aggregate function, but in this time we're going to focus on how to filter your result based on the aggregate functions. Okay, the first problem is use product vendor table, find the vendors whose average delivery days are less than 5 days. So basically for this one, from the product vendor table, we need first find out what are the average delivery days for each vendor, and then filter by those delivery days is less than 5 days. To do that, we cannot use where, because as we mentioned in the lecture, once you apply the group by, when we apply the aggregate function, and where actually cannot be used, because where can only use variables that is part of the origin table, the original columns in the table. But the average days to deliver, and we name it as average underscore day, is not part of the table in the product vendors, so we cannot use where. But luckily, we do have another clause for us to use, which is having. Having is the right way where you have a variable created by aggregate function, and then you want filter upon that. So in this particular example, we're trying to find out vendors and their average days to deliver, and then filter by the average delivery days less than 5. So we have this group by clause here, followed by having the average delivery days less than 5. Let's see what will happen. So only choose 3 vendors, their average delivery days is less than 5. Okay, the next problem is use product vendor table, find the products that their maximum wholesale price is higher than 1,000. This is very similar to the previous one. We want to find out the product number. For each product number, what is the maximum wholesale price? We're going to name it as the max price, and then filter based on the max price, which is larger than 1,000. Let's see. We found out 2 products. Product number 2 and product number 11. Their maximum wholesale price is larger than 10,000. The last one. Last one is only consider vendor ID between 5 and 10. Find the product's average price. Find the products that their average price is less than 25. Here, there's another filter. Okay, the third problem is a little bit more complicated because the first constraint is we want the vendor ID to be between 5 and 10. And vendor ID is actually one of the original variables in the product vendor table. Let's look at it. In the product vendor table, we have product number, vendor ID, wholesale price, and days to deliver. So the vendor ID is part of your original column in the table. So the vendor ID between 5 and 10 is going to be constrained by the where clause here. So you must use where to filter on the columns that is already part of your original column. But the average price, on the other hand, is from the aggregated function. So there's a group by for each product number, and we're going to use a having clause to have the average price less than 25. So in this example, we have 2 filters. First, we limit our data from the vendor ID between 5 and 10. Those are the limited data that where we're going to apply the group by aggregate functions. After we apply the group by and the aggregate function, we're going to filter again for products their average price is less than 25. So we have 2 filters in this case. One is using where with the original columns and having an aggregate function. Okay, now let's come to homework 11. Homework 11 is going to tell us how to update a particular variable in a particular row and particular column. Okay, in this one, we're going to use the sales order database. In the orders and order details table, reduce the quoted price by 5% for orders shipped more than 4 days after the order date. So sometimes the customer is not going to be happy because your order was shipped pretty late. So for those cases, we want to reduce the price for 5%. Okay. To do that, we have the orders and order details table. Let's look at what is inside. Orders table, we have the ship date and order date, but there's no price information. Order detail, it has the price information, but there's no ship date information. So we need to use both information to make it happen. How to do that? Ultimately, we want to update the order detail where the quoted price need to be reduced by 0.05. Okay, ultimately we have to update the order detail table, and we're going to set the quoted price to be quoted price times 0.95. But this is not for all the orders, okay? It's only for limited order. The order where their ship date and order date is larger than 3. Larger than 3, which means 4 days or more delayed. Okay? And try to find out the order numbers in those categories. We're going to use this subquery where we have the order we're going to select the order number from the orders table, where the date diff function is going to tell us how many days different between the ship date and order date. When we set those to be larger than 3, it's going to give us the order numbers that we need to update the quoted price. And then, as I mentioned earlier, when you are actually doing the update, it is permanent. And you need to do a quick check. The quick check is basically select the quoted price from the order detail table where this condition apply. Let me put in the checking condition here. It's going to be select quoted price from order details table, and we're going to use the same criteria shows here. Okay, that's right. So we're going to replace quite a lot quoted price here. If we confirm that's the right way to do, then we can do it using the update function. The use update function is going to tell you how many rows has been affected by this particular update function. So yes, sometimes you have to be very careful, because once you have the update function, it is permanent. Next, on homework 12, it is all about how to insert some new record in your table or delete some record from your table. And in SQL Workbench, it is fairly straightforward. For insert, you can insert into a particular table with all the columns, or selected columns will be good as well. And what is the value for those selected columns? And let's write. It mentioned one row has been affected because we inserted one row. And to delete that row, as we mentioned earlier, to delete, you usually need to do a quick check, because any delete will be permanent. Okay, if we want to delete employee ID equal to 710, what we're going to do is to do a checking first to see let's see. Sorry, this is going to be select. When you actually check the deleted, which row to delete, you need to use the select statement. In your select statement, you find out there's only one row to be deleted, and that's the right one to be deleted. So then you can use the delete statement to delete that particular row. And as you can see, for the employee table, there are more rows than what we defined in the insert table. So for any of the rows that is not part of your, for any of the column that is not part of your original variables, when you insert, there will be a null value for them. Okay, so you can see that the street address, birth date, phone number, etc. is not part of the information, so those information will be missing value. It is null. Okay, we can delete that, and then there's no more employee ID 710. So that's all for the homework solutions. And for this week, there's no homework. But after you read through the scripts of the homework solution as well as the course video, make sure that you understand, because our final exam will be heavily depend on the last few homeworks after the midterm, and because the nature of this course, anything that we mentioned before the midterm exam will be also might be also included in the final exam. But we're focused more on the content that we learned after the midterm exam. That's all for today. See you next time.